एनवी कॉमर्स एकेडमी में आपका स्वागत है। हमारा आज का टॉपिक है स्टैंडर्ड डेविएशन। स्टैंडर्ड डेविएशन एक इम्पॉर्टेंट मेज़र है डिस्पर्जन का। डिस्पर्जन को कैलकुलेट करने के लिए हम इसे यूज़ करते हैं और स्टैंडर्ड डेविएशन को फर्स्ट ऑफ ऑल इंट्रोड्यूस किया था कार्ल पियर्सन ने। हम स्टैंडर्ड डेविएशन की कैलकुलेशन को स्टडी करेंगे इसमें। सो फॉर कैलकुलेशन ऑफ स्टैंडर्ड डेविएशन सबसे पहले कवर करते हैं इंडिविजुअल सीरीज़। इंडिविजुअल सीरीज़ में स्टैंडर्ड डेविएशन को कैलकुलेट करने के लिए हमारे पास 3 मेथड हैं। फर्स्ट मेथड का नेम है एक्चुअल मीन मेथड, सेकंड मेथड है एज्यूम्ड मीन मेथड और हमारा तीसरा मेथड है मेथड बेस्ड ऑन एक्चुअल डाटा। सबसे पहले एक्चुअल मीन मेथड। जब हमें स्टैंडर्ड डेविएशन को कैलकुलेट करना है एक्चुअल मीन मेथड से, तो हमारा फॉर्मूला स्टैंडर्ड डेविएशन को कैलकुलेट करने के लिए समेशन स्मॉल एक्स स्क्वायर डिवाइडेड बाय एन। सो स्मॉल एक्स इज x माइनस एक्स बार। जब हम हमारी ऑब्जर्वेशंस की डेविएशंस को काउंट करते हैं फ्रॉम एक्चुअल मीन, हमें उन डेविएशंस का स्क्वायर करना है, उसे सम अप करना है, n से डिवाइड करना है और स्क्वायर रूट करना है, तो हम स्टैंडर्ड डेविएशन को कैलकुलेट कर सकते हैं। इसको क्लियर करते हैं। x इज गिवन 16, 20, 18, 19, 20, 20, 28, 17, 22 and 20. These are 10 observations in number, so n hereby is 10. For calculation of actual mean, I need to sum up the series. So sum total of observations 200. So mean here is summation x divided by n. 200 divided by 10 gives us 20. Actual mean is 20. So we need to take deviations, that is small x minus x bar means 20. X minus 20, 16 minus 20, minus 4, 0, minus 2, minus 1, 0, 0, 8, minus 3, 2 and 0. We need to square these deviations. So 4 square 16, same as 0, 4, 1, 0, 0, 64, 9, 4 and 0. For calculation of standard deviation, I am repeating the formula, that is summation x square divided by n. So sum of squares of these deviations can be summed up as 98. 98 divided by 10 under root. Root 9.8 gives us 3.13. Our second method is assumed mean method. जब एक्चुअल मीन एक होल नंबर नहीं होता और हमारा जो आंसर है मीन का वो डेसिमल में है, होल नंबर नहीं है, तब हम assumed mean method को अडॉप्ट करते हैं. According to this method, formula for calculation of standard deviation is given as summation d square divided by n minus summation d upon n whole square under root. D here is deviations taken from assumed mean. It can be clarified with an example. Let's take x 240, 260, 290, 245, 255, 288, 272, 263, 277 and 251. These are again 10 observations and hereby is 10. For calculation of actual mean, sum of this series is 2641. By dividing sum of observations by number of observations, mean here is 264.1, which is not a whole number. When mean is not a whole number, then we will resort to assumed mean method. So we need to take deviations from assumed mean. So first of all, we have to assume a mean from the following observations. So hereby I am taking assumed mean 264. By these observations, we can choose any observation, but here mean is 264.1. So I am taking assumed mean as 264. So 240 and 264. Gap is minus 24, minus 4, 26, minus 19, minus 9, 24, 8, minus 1, 13 and minus 13. Deviations square. 24 square 576, 16, 676, 361, 81, 576, 64, 1, 169, again 169. Formula for application is summation d square upon n minus summation d upon n whole square under root. So summation d square, sum of squares of these deviations give us 2689. Sum of deviations provides us 1. So 2689 divided by 10 minus 1 upon 10 whole square under root. इसे छोटे छोटे स्टेप में सॉल्व कीजिए. 268.9 माइनस 0.1 होल स्क्वायर. 268.9 minus 0.01 gives us 16.398 as answer of standard deviation. Our next method is method based on actual data. When our observations are few in number, then we can choose this method. Formula for calculation of standard deviation by this method is summation x square upon n minus summation x upon n whole square under root, or we can write it as summation x square upon n minus summation x upon n gives us arithmetic mean. So x bar whole square. Clarification with an example. Let's take observation 16, 20, 18, 19, 20, 20, 28, 17, 22 and 20. These observations are 10 in number. So we can square these values. 16 square 256, same as 400, 324, 361, 400, 400 again, 784, 289, 484 and 400. Sum total of Square of these observations 4098 and sum of observations are 200. So application in the formula, summation x square 4098 divided by n, that is 10, minus 200 upon 10 whole square under root 409.8 minus 20 square 400 gives us 9.8. So answer for standard deviation is 3.13. So if we need to calculate standard deviation for individual series, we have three methods. First method is actual mean method, second was assumed mean method, and the third one was method based on actual data. If mean is whole number, then we can opt first method. If mean is not whole number, then we can choose second method, and if our observations are few in number, then we can resort to method based on actual data. Next series, discrete series. In discrete series, again there are three methods for calculation of standard deviation. First, actual mean method. Second, assumed mean method, also known as shortcut method. And third method here is step deviation method. In actual mean method, our formula is summation fx square divided by n. Formula for individual series, it was summation x square upon n, but in discrete series frequency exists, so we have to multiply square of these deviations taken from actual mean with frequency, then we will get fx square. By summing up that column, we will get summation fx square. We have to divide it by number of observations, and root of this gives us standard deviation. For assumed mean method, formula is summation fd square upon n minus summation ft upon n whole square. Again, frequency gets multiplied with these deviations taken from assumed mean. For assumed mean method, x is given 3, 4, 5, 6, 7, 8 and 9. Frequency 7, 8, 10, 12, 4, 3 and 2. So, according to assumed mean method, we have to take assumed mean. So, 6 here is assumed mean. So, D is x minus a, x minus 6. 3 minus 6, minus 3, minus 2, minus 1, 0, 1, 2 and 3. According to formula, we need fd and fd square. For ease of students, they can calculate d square. 9, 4, 1, 0, 1, 4 and 9. By multiplying deviations with frequency and deviations square with frequency, we will get fd and fd square. So first of all, fd, 7 into minus 3, minus 21, same as minus 16, minus 10, 0, 4, 6 and again 6. For fd square, fd square, 7 into 9, 63. Same as 32, 10, 0, 4, 12 and 18. इन दोनों कॉलम्स को सम अप कर लेंगे. -31 and 139. So last step here is application in the formula. Summation FD square upon n. 139 upon 10 minus -31 upon. हमें यहाँ पर फ्रीक्वेंसी को सम अप करना है फॉर n. So it is 46. I'm correcting here. 46 square. So 3.0217 minus 0.4541. It will give standard deviation 1.602. Third method is step deviation method. Formula for step deviation method is summation ft dash square upon n minus summation ft dash upon n whole square multiplied by I, that is common factor. So what is d dash over here? Deviations from assumed mean when divided by a common factor, it gives us d dash. Our next series, continuous series. In continuous series, again there are three methods: actual mean, assumed mean and step deviation. The most probable method here is step deviation method. Formula is same, but d dash for continuous series is mid value minus assumed mean divided by common factor. So taking example for a continuous series, let's take x 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, the last is 70 to 80. Frequency here is 5, 10, 20, 40, 30, 20, 10 and 4. We need to calculate standard deviation here. So first of all, we'll write down the mid values: 5, 15, 25, 35, 45, 55, 65 and 75. For deviations, we need to assume a mean. So for assumed mean, I am taking 35 here. So D is equal to x minus 35. 5 minus 35 minus 30 minus 20 minus 10, 0, 10, 20, 30 and 40. D dash, common factor here is 10. So I'll divide D by a common factor 10. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. D dash is there. Again, for your easiness, you can square the D dash. 9, 4, 1, 0, 1, 4, 9 and 16. So at last FD dash और FD dash square. Frequency से D dash को multiply कर लीजिए. 5 minus 3 minus 15 minus 20 minus 20, 0, 30, 40, 30 and 16. For FD dash square, 45, 40, 20, 0, 30, 80, 90 and 64. Application in the formula. summation ft dash square upon n minus summation ft dash upon n whole square multiplied by I. So sum of frequency n here is 139. Summation ft dash square. Sum is 369 and 61. So 369 divided by 139 minus 61 divided by 139 square, that is under root, multiplied by common factor, that is 10. So by solving 2.6546 minus 0.1925 multiplied by 10, so 1.569 multiplied by 10, standard deviation is 15.69.